Hey guys, we're going to jump into a ton of exponents tonight, and I think we're going to see some big bears, but it's nothing that you can't tackle or handle. I know that for sure. So, probably when we're all done with the video, one of our big goals is that we're going to be able to handle problems like this bear or this bear and be able to simplify them all the way, and also have a degree of confidence as to like what does it mean to be fully simplified? How do I know I've gone as far as I can and I've taken care of all my business? So we're going to jump right into our properties, and we've got 7 of them that we want to cover today. And the first one's called the negative exponent rule. And basically, it says if you've got b raised to the negative n, that's equivalent to 1 divided by b to the positive n. So a popular example might be, 7 to the negative 2, which is rewritten as 1 over 7 squared, which is equivalent to 1 over 49. Now, where it gets a little more complicated is if I put like in this case, 4 to the negative 2 on the bottom. Like it's already on the bottom. So what I'm going to do is I'm going to rewrite the denominator as 1 over 4 squared. In fact, that numerator, I'm going to erase that 1, and I'm going to rewrite that as 1 over 1, and I'm going to do what I call a keep change flip, where I keep the top fraction, change to multiplication, and then flip that bottom fraction, and you're going to end up with 4 squared or a positive 16 when you're all done. So that gets a little more complicated when it's a negative exponent. It's already on the bottom, but nothing we can't handle, of course. All right, the zero exponent rule says anything raised to the 0 is guaranteed to be 1. So we could have, 7 to the 0 is 1, negative 4 in parentheses to the 0 is 1. But watch this bear trap right here. So it's a matter of how we interpret this. See, there's no parentheses, right? So technically, who is being raised to the 0 power? It's only the 4. Okay. So in other words, there's like this really discrete, invisible set of parentheses right there. And of course, 4 to the 0 makes 1, but then now you have that negative. So the final answer would be negative 1. All right. Now we get into our product rule, right? And we said, okay, let's say we're multiplying 2 terms that share the same base. Okay, this term and this term, they both have a base of b. And when you want to multiply them together, all you have to do is maintain that base. Okay, see how that's still a b? And then just add the exponents. So if I have 2 to the third times 2 to the second, well, that's just going to be 2 to the fifth. Because, of course, this one's 8, this one's 4, and then this one makes 32. What if I have x? What if I have x to the 7th times x to the negative 2? Well, I'm still going to add them and get x to the 5th. Now we're going to introduce you to the power rule, right? And so you've got this b that's already raised to the m. We wrap that up with parentheses and say, I want to raise that entire expression to the nth power. All we're going to do is just multiply those exponents. So if I've got negative 2, I won't throw in a negative there. I'll just keep it a positive. So we'll say 2 to the third to the 5th. All we're going to do is multiply the 3 and the 5 to make 2 to the 15th. Or maybe we have x to the 7th, and that's raised to the negative 2. We'll just multiply them to make x to the negative 14, which would be 1 over x to the 14th when I'm all done. What do you think's coming next? Yeah, I got a little quotient rule for you. So it says, all right, let's take these 2 terms. They both have the same base, and if you want to divide them, you can. Just maintain your base and subtract your exponents, and you are good to go. So maybe I have 2 to the 5th divided by 2 squared. I'm going to got to maintain the base and then subtract those exponents. Or maybe I have x to the 7th divided by x to the negative 2. Now watch this. If I subtract them, in my head, if I think 7 minus negative 2, I'm actually going to get 9 because of the double negative. The next 2 are sometimes they're very intuitive, and sometimes we take them for granted, but I just want to throw them out on the table so we kind of all agree on these. It's almost like you're distributing the exponent, right? It's almost like you're distributing that exponent. So we're saying, okay, the product of a times b raised to the nth is just a to the nth times b to the nth. So let's look at an example of this bear. Maybe we've got the quantity negative 2y raised to the 4th. So your product is right here. And, negative 2 is your first term, y is your second term. So I'm going to rewrite this as negative 2 with parentheses raised to the 4th. and then the y with parentheses to the fourth. And that's going to make positive 16y to the fourth. Or maybe I've got negative 2x squared y to the negative 3 to the third. Well, I'm going to rewrite this as negative 2 to the third, x squared to the third, and then y to the negative 3 to the third. And that's going to make negative 8, x to the sixth, y to the negative ninth. Or I could say negative 8, x to the sixth, all over y to the ninth. So that's a real big bear there. And the very last one, we mentioned there's going to be 7 rules. This is the quotient raised to powers. Again, it's kind of like distributing that exponent to both the numerator and the denominator. And it's a very subtle move that kind of, it takes this big, ugly problem and breaks it into smaller, more manageable pieces. And that's all we're trying to do. We're trying to win the problem step by step, really. So let's see what a couple of examples look like. Maybe I have a fraction like 2/5 and it's raised to the 4th power. So you could think 2 to the 4th. You could think 5 to the 4th. Again, we just broke it into more manageable pieces. And I think that's, oh boy, 5 to the 3rd is 125. So that's going to make maybe 625, I think, off the top of my head. Hopefully, if I got that wrong, you can laugh at me and comment in this comment section below. Maybe I have negative 3 over x to the 3rd. Now, one thing to watch out for, that negative, they may put the negative right here. And if they put it dead center like that, I like to move it to the numerator specifically. Okay, so I'm thinking negative 3 to the 3rd. I'm thinking x to the 3rd. And that's going to make negative 27 because a negative times a 3rd negative always makes a negative all over x cubed. And we're all done. So now we're going to, one last thing here. We talked about how do you know you're done, all right? If we can go through this mental checklist, and I've never really included this in my notes before, but we're going to throw it out there on a trial basis and see if this helps us. We got to first make sure that if you think you're all done, we got to make sure there's no parentheses left, right? We got to make sure there's no powers raised to another power. We got to make sure that each base occurs only once. Like you shouldn't have an x in your numerator and an x in the denominator and think you're done. That means we still got more work to do. There shouldn't be any negative exponents and there shouldn't be any zero exponents. Otherwise, we got more work to do. All right. So our first live example, I'm going to kind of distribute. I'm going to use property number 6. I'm just going to make kind of that note right here. I'm going to use property number 6 and rewrite this as negative 3 to the 3rd, x to the 5th to the 3rd. Just such a big fan of good parentheses. And that's going to make negative 27, x to the 15th, y to the 9th. And that's all she wrote when she's all done. And again, this looks like almost the exact same problem, except now you've got that 30th exponent. And the only reason I threw this example in there is because there is another way that you could do this problem, right? You could say to yourself, I'm going to rewrite this inside quantity. I'm going to highlight it here. I'm going to rewrite negative 3, x to the 5th, y to the 3rd. I'm going to rewrite it 3 times because of this exponent and then just multiply them together. And that's totally cool as long as this exponent's small enough where you feel like rewriting it that many times. But when I saw the 30th, I'm like, I'm not going to rewrite this 30 times. So you would really want to use property number 6 that I just demonstrated on the example above it. Okay, let's just multiply like pieces, right? I'm going to be super redundant here and probably show more work than you want me to. But I'm thinking negative 7 needs to multiply the negative 3. The x squared needs to multiply the x. And the y to the 8th needs to multiply y to the 5th, right? So I'm just kind of reorganizing the terms. And technically, that's called the commutative property that says, hey, when you're multiplying, you can kind of shuffle these in any order you want. So the product there is going to be 21. The product here is going to make x cubed. And the product right here is going to make y to the 13th. And you're all done. So we're just adding those exponents as we multiply like bases. Kind of in a similar fashion, it's all about the way I rewrite this. The first thing I'm going to do is I'm going to take negative 40 and I'm going to divide it by 8. Okay, there's one term. Then I'm going to take x to the 3rd and I'm going to divide it by x to the 10th. And then I'm going to take y to the 6th and divide that by y to the negative 2. So this first term makes negative 5. I'm going to subtract these exponents to make x to the negative 7. And subtract these exponents to make y to the 8th. Again, watch out for the double negative. Remember, it's 6 minus negative 2, right? So that's going to give you your 8. Now, if you check that checklist just above this slide, we want to make sure there's no negative exponents in my final answer. It's okay to have negative coefficients like -5. We just don't want negative exponents. So I'm going to say -5y to the 8th divided by x to the 7th when I'm all done. All right, speaking of crazy bears, check this one out. And again, for me, it's all about rewriting and distributing that exponent. So I'm thinking first it's going to be 2 to the -3. And then it's going to be x cubed to the -3 all over y to the -3. Now, let's see. There's a couple different avenues we could take. But the first one I'm thinking is when I see 2 to the -3, I'm thinking 1/8. And x cubed to the -3 is going to make x to the -9. And then I got y to the -3. So it's all about how you rewrite this. Well, with regards to the 1/8, I'm going to commit the 1 to the numerator and the 8 to the denominator. I'm going to put x to the 9th on the bottom, which makes the exponent positive. I'm going to put y cubed on top, and that's all she wrote. I think I want to show you another trick on this problem and just give you a different perspective, and maybe you'll like this one better. There's a good chance you might like this one better. My very first move is to reciprocate this inner function and put the y on top and the 2x cubed on the bottom. And you're wondering, why in the world would you reciprocate that? Well, what it does is it makes this exponent positive, okay? And then you can distribute and go y to the third, 2 to the third, x cubed to the third. That got a little messy. And then you get your 8x to the 9th. And you'll notice we got the same answer, probably a little bit easier too. So one trick I like to do is I'm going to reciprocate or flip this bear and then just change the sign of that exponent. And it works every time. It's totally legal. All right, what else we got cooking up our sleeves? Holy smokes, that's the last one. How about that? That's a good surprise. So I hope you feel all right about these exponents. We're going to keep chugging. And before you know it, you're going to be amazing at handling these exponents.